In this video, we will talk about the 45, 45, 90-degree triangle and the trigonometric functions sine, cosine, and tangent of 45 degrees. This is one of the special right triangles in trigonometry. So let's have a right triangle, and one of the acute angles will have the measure of 45 degrees. And if this angle is a 90-degree angle and this one is 45, then the other angle is also 45. And that is because in a triangle, the sum of all three angles has to measure 180 degrees. Now, let one of the shorter sides be equal to 1. Then, because these two angles are equal, these two sides are also equal. So then, the other side will also be 1. In other words, if in a triangle two angles are equal, then their opposite sides are also equal. Now, once we have these two sides, we can find the hypotenuse by applying the Pythagorean theorem. Let's call the hypotenuse C. Then C equals the square root of one side squared plus another side squared. And square root of 1 squared plus 1 squared equals square root of 2. So we just found the hypotenuse, and the hypotenuse is square root of 2. Now let's find sine, cosine, and tangent of 45 degrees. We will start with sine of 45 degrees. And by definition, sine of an angle is the opposite side divided by hypotenuse. That is 1 divided by square root of 2. And now to rationalize the denominator, we will multiply the numerator and the denominator by square root of 2. Then in the numerator, 1 times square root of 2 is square root of 2, and in the denominator, square root of 2 times another square root of 2 is 2. So here we found the value of sine of 45 degrees, and that is square root of 2 over 2. Now let's find cosine of 45 degrees. By definition, cosine of an angle is the adjacent side divided by hypotenuse, and that is again 1 over square root of 2. Now let's multiply the numerator and the denominator by square root of 2, because we need to eliminate the square root from the denominator. And again, we will get square root of 2 over 2. So cosine of 45 degrees is also square root of 2 over 2. And now let's evaluate the tangent of 45 degrees. By definition, tangent of an angle is the opposite side divided by the adjacent side. In this triangle, that is 1 divided by 1, which equals 1. So tangent of 45 degrees equals 1. So these are the values of sine, cosine, and tangent of 45 degrees, and this is regardless of the lengths of the sides in this 45, 45, 90-degree triangle. For example, now let's have another right triangle, and here again the acute angles are 45 degrees each, but now the length of each side will be 5 units. Now to find the hypotenuse C, we will take the square root of 5 squared plus another 5 squared. 5 squared is 25, and 25 plus 25 is 50. To simplify square root of 50, we will write it as a product of 25 and 2. Then square root of 25 is 5, and we will keep 2 inside the square root. So we just found C, and C equals 5 square root of 2. Now let's find sine, cosine, and tangent of 45 degrees using this triangle. Sine of 45 degrees equals opposite side divided by hypotenuse, and in this triangle the opposite side is 5 and the hypotenuse is 5 square root of 2. Then 5 and 5 will cancel, Then from here we will multiply the numerator and the denominator by square root of 2. Then the result will be square root of 2 over 2. So as you see in both these examples, we got that sine of 45 degrees is square root of 2 over 2 regardless of the lengths of the sides of these triangles. Now let's also find the cosine and tangent. The cosine function by definition is the adjacent side divided by hypotenuse. And in this triangle, that is also 5 divided by 5 square root of 2. Then 5 and 5 will cancel, and we will multiply the numerator and the denominator by square root of 2, and the result will be square root of 2 over 2. And this value is the same as the one in the first example. And now to evaluate tangent of 45 degrees, we will divide the opposite side by the adjacent side. That is 5 divided by 5, and all this equals 1. And now we see that all these values are the same as the values that we got to the left. Now let's talk more about the relationships between three sides in a 45-45-90 degree triangle. Notice that in this triangle, if these two shorter sides are 5 and 5, then the hypotenuse is 5 multiplied by square root of 2. In the triangle to the left, the shorter sides are 1 and 1, and we can say that the hypotenuse is 1 times square root of 2. This means that if we know one of the shorter sides in such a triangle, then to find the hypotenuse, we just take this side and we multiply by square root of 2. In general, if we have a 45-45-90 degree triangle and each of the shorter sides is x, then the hypotenuse will be x multiplied by square root of 2. For example, if this side is 7 and this side is 7, then the hypotenuse will be 7 times square root of 2. And if the hypotenuse is 7 square root of 2, then this side is 7 and the other side is also 7. So again, in all these triangles, if we are given the lengths of the shorter side, then to find the hypotenuse, we just multiply it by square root of 2. But what if in a triangle like this, we are given the hypotenuse and the hypotenuse is represented by a whole number? Then how would we find the other two sides of this triangle? For this, let's see an example. So here we have the right triangle, and let the hypotenuse be equal to 8 units, and each side x units. Then I will show you how to find x using two methods. In the first method, I will just use the Pythagorean theorem, and that is one side squared plus another side squared equals the hypotenuse squared. Then on the left side, x squared plus another x squared is 2x squared, and on the right side, 8 squared is 64. Now, if we divide both sides by 2, we will get that x squared equals 32. Then x will be equal to square root of 32. And to simplify this radical, we will write 32 as a product of 16 and 2. Then square root of 16 is 4, and we will keep 2 inside the square root. So we just found x, and x is 4 square root of 2. And now let's see the second method. From this video, we know that in a triangle like this, if this side is x and this side is x, then the hypotenuse will be x times square root of 2. So let's write that the hypotenuse is x square root of 2. In this example, x square root of 2 is equal to 8. Now we can just take this equation and solve it for x. So we have that x square root of 2 equals 8. And to solve for x, we will divide both sides by square root of 2. Then on the left side, square root of 2 will cancel, and x equals 8 over square root of 2. And to rationalize the denominator, we will multiply the numerator and the denominator by square root of 2. Then in the numerator, we will have 8 square root of 2, and in the denominator, square root of 2 times square root of 2 is 2. Here we can divide 8 by 2 and get 4. Then x will be equal to 4 square root of 2. And here we got the same result as in the method to the left. So we can say that if this side is 4 square root of 2 and this side is 4 square root of 2, then the hypotenuse will be 8. This is all for this video. I hope you enjoyed it. Please subscribe and thank you for watching.